We are going to be looking at two problems from section 5.2. This section is on logarithms, and we are asked in here to use the property of logarithms to rewrite each expression as a single logarithm. Before I can get started, I need to get my pointer set up, and it's always good to have a color other than red, I am told. And so here we go. Using this here, what we're going to do first is using our different properties. I can begin by looking at this first one here, and I'm going to use the power property, and I'm going to rewrite this 1/3 log of y as the following. So I'm just going to rewrite the log of x, and so that's not changing. So I'm going to have the log of x, but then this here I'm going to change to, we're going to have the log of, this would be y raised to the 1/3 power. That would be equivalent to the following if you want. That'd be the same thing as the cube root of y if we want to write it that way pretty soon. We don't need to do that, but we can. Since the textbook answer is that way, I'm just going to do that step next. And so this is the same thing as, if I rewrite this, this would be the log of, this would be the same thing then as the cube root of y. Remember, for fractional exponents, we can rewrite them with radicals. Now, our next step, taking it from here, we can use the quotient property, and in the quotient property, taking that backwards, remember, if we have subtracting two logarithms with the same base, that's the same thing as a logarithm of the quotient. And so our final answer for this thing is going to be the log of the following, and we're going to have, in the numerator we have the positive part, and in the denominator we have the negative part, so we have the cube root of y. If you want, you can put parentheses around this, and this finishes problem number 36. On problem number 38, we're going to start out similar to what we did on 36 here, and I'm going to first of all take care of the 6 in front of the logarithm and the 2 in front of the logarithm. And so this is going to be the same thing as the natural logarithm of, and this is going to be 5, I'm going to use double parentheses here. This is going to be 5y, that's all to the 6th power, and it's the natural logarithm of that. And this over here is going to be the natural logarithm of x squared. So this is using the power rule, or the power property for logarithms. And now with the sum of this here, what we can do is we can rewrite this in the following. This would be the same thing as the natural logarithm of. Okay? And then we're going to have the same 5y to the 6th power, but I'm going to write that as 5 to the 6th power, y to the 6th power. And then our product property is going to say that when we have an addition of two logarithms, that's going to be the same thing as the product. And so this is going to be then times x squared. This is an answer for this problem. If you want, you can multiply out 5 to the 6th power. I'll do that offline here. I'm just going to take out my calculator and punch in what 5 to the 6th power is. So 5 raised to the 6th power is a big number, and so if I come back here, I can rewrite this then as the natural logarithm, and then 5 to the 6th power is going to be 15,625, so I have 15,625. And let me just put these in alphabetical order. So I'm going to have x squared and y to the 6th. And that's my answer for this problem. This completes problems number 36 and 38 from section 5.2.